Okay, so today we're starting with this thing called inverses. We don't know about the word inverse. Opposite? When you think about math, though, and you think about the word opposite, what does that mean? Negative. Yeah, like if it's positive, it'll change to negative. It's not quite that. So inverse is a little different than just the word opposites when we talk about math. But it's a very simple concept. And that's what we're going to do today. So let's get started. When we talk about a function, we used to do this thing. It was called a vertical line test. And a vertical line test would tell me whether or not something was a function. Y'all remember how it did that? To be a function, an input would give me how many outputs? Just one. So a vertical line test would tell me for every x value, if there's more than one y value, it cannot be a what? It cannot be a function. Okay, so for example, in this particular problem that is mapped here, we have the function 2x plus 1. See that? So what happens is literally you input a value for x, and it will output the value for what? For y. So for this problem, if I plug 3 into the function 2x plus 1, what's 2 times 3? And then 6 plus 1 gives me a 7, right? So for every input, there's one output. Same thing for negative 2. If I plug it in, the output's negative 3. Same for 5. 2 times 5 is 10. 10 plus 1, 11. So for every input, there is an output. Okay, so when we have the inverse to that function, for example, when we talk about inverses and y'all's immediate word was opposites, it's not opposite the way we use the word opposites in math, and y'all said that. Like, for example, if something was a positive 5, what's the opposite? Negative 5. It doesn't do that, but here's what an inverse will do. It'll take the input and the output for a function, and the inverse to that function will simply do what with those inputs and outputs? It flops them. So, for example, if I had the inverse to the function 2x plus 1, if I plugged 7 into that inverse function, guess what it would give me? It would give me a 3. If I plug negative 3 into that inverse function, what would it give me? Negative 2. If I plug 11 into that inverse function, guess what it would give me? Positive 5. It takes the x's and y's for a function, and the inverse function will flip them. Okay? Doesn't change the signs. It just swaps them. Okay? It's a very simple concept. So we're going to do three main things today. One, we're going to determine whether or not a function can even have an inverse. And we do that with a calculator. All right? Real simple. If it does have an inverse, then second thing we're going to do is we're going to write the inverse. It's really easy. Okay? Here's how easy it is. If you think about that concept right there, how the x's and y's literally flip, the deal with a function and its inverse, the inverse has to undo what the function did. Okay? With that being said, if a function is adding 5, guess what the inverse function has to do? It has to subtract 5 somewhere in the function. If a function is multiplying by 2, guess what the inverse has to do? It has to undo that. It has to divide by 2. You see, an inverse and its original function are going to undo one another, essentially. So the process of writing an inverse is really simple. Okay? And then the last thing we're going to do, see, 3 things, and this is all calculator. Once you've written the equation for the inverse of the equation that you had originally, you're going to graph them all, and you're going to compare them to this one line, and then you'll know whether or not you wrote the inverse correctly. It's really simple, okay? So, first thing we're going to do is we're going to use this thing called a horizontal line test. A horizontal line test. The horizontal line test will determine whether or not a function has an inverse. Okay? So a vertical line test did what? No, the vertical line. What did the vertical line test do? It tested if it was a function. A horizontal line test will test whether that function has a what? Inverse. One more time. A vertical line test will test whether something is a function. A horizontal line test will test whether that function has a inverse. If it doesn't pass the horizontal line test, you don't do step 2. Okay? You literally just write no inverse. It's really simple. Okay? So, after you have done the horizontal line test, again, like we said, if it doesn't work, you're going to simply write no inverse. But if it does work, you're going to move to step 2. And step 2 is where you take the function and you undo it. And the way that you undo a function is you switch x and y and you solve for y. Okay? That's how you do it. It's really, really simple. Because all that requires is you to solve an equation for another equation. And y'all have done that. Y'all have gotten y alone, haven't you? That's all you're doing. You're switching x and y and you're solving for y. Now, step 4 is just about the way we write it. Most of the time, these original functions are going to be in what we call function notation. What's function notation mean? What does it look like if it's in function notation? What's an example of function notation? Don't overthink it. Yeah, f of x. So if it's in function notation, f of x, and then you go through the process of writing the inverse, you're not going to call the inverse f of x. You got to distinguish it from the function. So you're going to write f of negative 1x. Okay? When you have that negative 1 as like a postscript, it's indicating that, hey, this is the equation for your inverse. So f of x is the function, f of negative 1x is the inverse. Okay? Really simple. And then the last thing you're going to do is you're going to go back to your calculator. You're going to graph all of these along with the equation y equals x. Y'all know what the graph of y equals x looks like, don't you? It's got a slope of what? 1, right? So it rises 1, run 1. So it goes right through the origin, and it goes up 1, right 1, up 1, right 1. So it does this diagonal, right? Y'all can visualize this. So we're going to check to see if the function and its inverse reflect over that line, y equals x. Now, very, very occasionally, you have to limit the domain. I think in your homework, in the notes, we don't have one of these problems. In your homework, I think you have one. And I'm going to let you see it first, and then we'll talk about it. If I have a chance after I've gone through the homework or the notes, we might go look at the one that does it, but more than likely, it'll be tomorrow before we actually even see that happen. You'll see it on your own, but then we'll discuss it. So, 3 steps. Calculator. If you need to, switch x and y, solve for y. And then step 3, calculator again. Okay? So guess what we definitely need? We need our calculator. So let's go ahead and let's jump to A. And I'm going to stay over here the rest of the time and use the calculator. And I promise you guys are going to think this is really, really simple. What do you always need to do when you get your calculator out? Probably, unless it's your own personal calculator, I would definitely go second plus 712. I'm going to show you a couple of, one kind of different thing about a calculator today. We'll discuss that when we get to the third step. So first of all, let's go to the first step. We are just checking A to make sure what? To make sure not that it's a function, but that it has a what? An inverse, okay? We're going to check to see if it even has an inverse. So we're going to graph it, 3x minus 4, and I'm going to graph it, and I'm going to see whether or not this passes the what? The horizontal line test. So take your pencil, literally, and just drag it up that line. Do you ever hit 2 points at the same time? Is there a definitive place where it changes and goes back the upward or downward direction? There's no overlap for horizontal line test. So this does pass the horizontal line test. So it does have a what? It does have an inverse. So here we go. Let's go to our paper and let's find it. What did step 2 say? To find our inverse, we switch x with y. Do we have a y here, y'all? Yeah, remember f of x is another way of saying y, right? So we're literally going to switch it. And step 3 says what? Solve for y. Now, why do we do that? Why do we switch x and y and solve for y? Well, think about it. If my original function is subtracting 4, if I switch x and y and solve for y, inevitably, what am I going to end up doing? What's the opposite of subtracting 4? See, I'm going to add 4. It undoes what the original one did. Does that make sense? Look, if the original one was multiplying x by 3, what's this one going to end up doing at some point? What's the opposite of multiplying? It's going to divide by 3. You see, the purpose of switching x and y and solving for y is it allows your original function to undo. And that's what creates your what? Your inverse function. Very good. So that's what we're going to do. How do I solve this one? What's my first step I need to do? I need to add 4. So x plus 4 will now equal 3y. Is y alone? Nope. We got to what? We got to divide by 3. Now, will that leave y alone? Okay, so I'm ready to go ahead and write my inverse function, right? So here's the deal. If my original function was f of x, what are we going to name our new inverse function? F of negative 1x equals x plus 4 over 3. So I feel pretty good about what I've done here, right? So I'm going to go back, step 3, and I'm going to just make sure I did it right. So I go back to y equals, leave the original, okay? But let's do a fraction. How do we do a fraction? Alpha y equals number 1. We put what in the numerator? And what do we put in the denominator? Is that all we're going to graph? What else did I say we're going to graph? We're checking to see what? Over what line? So I need to graph y equals x, right? So I'm going to graph y equals x. Now, when you do that, now look at it. Does it look like it reflects?
From that line, yeah.
So it reflects over this middle line right here, right? You agree? Now, some people might say, well, kind of not. Here's why you would say that. It doesn't really, and here's why. Think about a window. Like, it's wider than it is tall, is it not? But how many units does it go left? That window, how many units does it go left? It goes 10 left. How many units does it go right? It goes 10 right. How many units does it go up? 10 up. How many units to go down? So if it's going 10 units in every direction, but the window is wider than it is tall, will there be a discrepancy in how wide all of those increments are left and right compared to up and down? And that's why it may not look exactly like it's reflecting. So there's one thing that you can do in your calculator where it'll fix that. So everybody do it. I want you to see this at least this one time. Most of the time you guys are going to look at this and you're like, well, remember, the window's a little wider than it is narrow or tall. So therefore, yeah, that's a reflection. But if you want to see it really, really nicely, go to zoom. And we're going to pick 5. That squares it up. And when it squares it up, you actually see a lot better. You guys are so loud. You're lucky I'm in a nice mood because I was thinking about cracking some skulls. You think I intimidated them?
No. 100% yes. Definitely.
I bet they're like black.
No.
They're shaped.
So if y'all look at that, y'all see how much clearer it is that they're reflecting? Like if I go diagonally from any point, if I go diagonally right here, it's going to be perfectly this direction, okay? Real simple, okay? So what does that mean? What was the whole purpose of doing that? Yep. We're just making sure we wrote our equation correctly, right? And how do we know that we wrote our equation correctly? Because of that reflection. So really the only purpose of this is just to like reassure myself that I did it right. So I did. So I'm moving on. Ready? Let's go to the next one. I'm going to clear these off. I'm not going to reset my calculator for one reason. I've already got it zoom and square. And I know that I'm doing inverses. So I want to just keep that, okay? Now, let's go to B. Y'all looking? How do I do cube root of? Y'all remember that? Where's that at? Math, number 4. And then we put our x minus 2 underneath it. Graph. We're checking right now to make sure it has a what? An inverse. So slide your horizontal line up your graph. Does it ever turn back where you're confident you're hitting 2 points at once? No. So does this pass the horizontal line test? Yes. So it does have a what? Inverse. So let's go write it. Okay, go back to your paper. Brady, how do we write our inverse? We switch. Come on, be with me. We switch x right here. We switch x with y right here. We switch them and we solve for what? Nuh-uh, it's already solved for now because I switched them. So we solve for y. All right, so here we go. Let's solve for y. Y's in there with a minus 2. So before we get rid of that minus 2, we got to get rid of the what? We got to get rid of that cube root, don't we? Yep, we cube both sides. We cube both sides. That's what's going to get rid of that cube root. So x cubed will equal, the cube root and the cube do what to each other? They cancel. And it leaves me with just y minus 2. And then I just add the 2. Now after I add the 2, am I done? Is y alone? Is y alone though? So what do we call it now? F of negative 1 x. Remember, all that's doing is it's saying, hey, your original function was f of x. We switched x and y and solved for y. So now my inverse, f of negative 1x, is x cubed plus 2. All right, now what? Brady, you with me? You don't look like it. I'm going to go to y equals. I'm leaving my original equation. I'm going to do x cubed plus 2. And I'm also graphing what, Landon? I'm also graphing x. Y equals x. Why? Because that's supposed to be what it reflects over. So here we go, graph. Does it look like a perfect reflection over that line, y equals x? Then we did it right. Okay, that was the whole purpose of doing that. Just to make sure we wrote our equation correctly. And to remember that that's what a function and its inverse have to do to each other. Listen, there's a problem or multiple problems on an EOC test where it literally gives you a graph of an equation, and it'll ask you which of the following functions is an inverse of that equation. If you can remember that they reflect over the line y equals x, all you have to do is go to your graphing calculator and graph the 4 answers they give you and see which one is a reflection of the line that's graphed. It's really simple if you understand that. If you remember that that's what a function and its inverse do, it makes a problem like that really, really easy. Okay? Also, if you can remember that a function and its inverse undo each other, you're going to know what to look for. Because if one of your equations is adding, the other one needs to subtract. And if one of them is multiplying, the other one needs to divide, so on and so forth. Okay? Let's go to C. All right, everybody knows how to graph this, right? Open parenthesis, x minus 4, close parenthesis, raised to the 2 divided by 3. Graph. What are we checking? Does this pass the horizontal line test? Does it? If I take a horizontal line and I run it up that graph, am I hitting 2 points at the same time? I am. So does this pass the horizontal line test? No. So are we going to go to our paper and switch x and y and solve for y? No. We're going to say no inverse. No inverse. Why do we say no inverse, Brady? Why did I say no inverse for that problem? What about it? That's right, it didn't pass. Hey, if y'all are getting ahead of me, which is fine, please change letter F, which is the last one we're going to do together. Will y'all change that to x is greater than or equal to -3? If you're ahead of me, I want you to see it right, okay? And I'm fine with you being ahead of me, but just make sure you change it to that. Okay, so D. D has one trick to it. So let me show you. If I just typed in the function, open parenthesis, x minus 1, close parenthesis, raised to the 4 divided by 3 power. If I just graph that, does it pass the horizontal line test? No. But they qualified what they wanted your x value to be, didn't they? Look at your paper. They don't want you to graph this whole thing. They want you to graph this with what restricted domain? X values that are 1 and above, right? So what we want to do is we want to tell our calculator to do that. So I want to show you guys how to restrict your domain on your calculator, okay? So go back to your equation and scroll all the way to the right. I want you to key press this so you will remember it, okay? So here's how we restrict our domain. We've written our function, and here's what's next. You're going to push divided by, and you're going to open up a set of parentheses, and you're going to tell them what your new domain needs to be. There's one button that if you don't remember, you won't know where to find it. So you're going to put your x. Is everybody caught up with me? And to get that inequality, you're going to go second math. Second math. And which one do we want there? We want number 4, greater than or equal to, and then 1. And then close that out. So what this did was it took our function and then it restricted our domain to only the x values that are greater than or equal to 1. Now if I graph it, does it pass the horizontal line test? See that? Okay, so because they limited the domain, we're going to find the what? We're going to find the inverse. So let's go and switch our x with our y, and let's solve for y. Now, hopefully you guys remember this. If not, no big deal. How do you get rid of a fractional exponent? You got to do another exponent. Do y'all remember what it was? How do you get rid of a fractional exponent? you raise it to the power of its, not denominator. It does include the denominator, but also its numerator. You raise it to the power of its reciprocal. So you're going to raise this to the 3/4 power. And remember, if you do it to one side, you got to do it to the other, don't you? Now let me just make sure you understand why we do that. If you do a power to a power, remember the rule? You multiply your exponents, right? And like Amani just said, 4 times 3 is 12. 3 times 4 is 12. 12 divided by 12 is what? It's 1. And what's anything raised to the first power? Itself. So it allows this to cancel. And we moved it to the other side. So here's what we're left with. X to the 3/4 equals y minus 1. What's my last step to get y alone? I add 1. Now, if my original function was h of x, what's my inverse going to be called? H of negative 1x. And there you have it. Now let's go check to see if we did it right. Y'all ready? Let's go over here to y equals. Let's leave the original just the way it is. And let's type in x raised to the 3/4 power. And then scroll down and put plus 1. Don't leave it up there. And then we're also going to type in what? We're also going to type in the equation x. And let's see if it's a perfect reflection. Is it? Perfect. Look, it reflects directly over that line y equals x, right on top of itself. Perfect. So we know we did it what? We know we did it right. Okay? Okay, we're going to skip E. We're going to jump to G real quick. Mainly just to show you guys, remind you how to type this in your calculator. But I would say most of you guys will remember, what is this type of graph? And did they restrict the domain? Guys, what's the graph of a absolute value all the time? It's like a V. Guys, will a V that hasn't been restricted ever pass the horizontal line test? No. I'm going to show you just to make sure you know how to type it into your calculator. To find the absolute value, the fastest way is alpha window, and right there it is, number 1, ABS. That's the fastest way. But if I type this in just like I see it, no restricted domain, you're going to end up, like we said, with a V graph. And a V graph will never pass the horizontal line test. So an absolute value graph will never have a what? It will never have a inverse unless they restrict the domain. So what are we going to write? We're going to write no inverse. No inverse. Okay, I want to do one more. I want to do F. And I want to do F for one main reason, because I want you guys to remind me how to write this in my calculator. So I'm going to do the easy part, the function, x plus 3 squared plus 1. That's the easy part. Now y'all remind me, how do I restrict my domain? Divided by, parentheses, x, second math, number 4, and then we're going to put our negative 3. There you go. Hopefully, you guys all are able to follow along with what was just done. That's how we restrict our domain. Now, does that create a graph that passes the horizontal line test? For sure. So let's go one more time, and let's switch our what? Let's switch our x with our y, which is here. And we've got x equals y plus 3 squared plus 1. All right. So to get y alone, what's the first thing that has to move? That plus 1. That's got to move. So, yep, we subtract 1. Now we got to get rid of that squared. Do y'all remember how to get rid of a square? you take the square root of both sides. Now, since x minus 1 is already on the other side, it all has to go where? It all has to go under the square root. So we've got the square root of x minus 1 equals y plus 3. Last step, will that minus 3 go under the radical or no? It will not. The x minus 1 is under there. The minus 3 is not. Now remember, if my original function was f of x, since this is my inverse, what do I call it? F of negative 1x. Very good. Now let's go check our work. Let's go make sure we did it right. Go back to y equals. Leave the original. We're going to do the square root of x minus 1. Don't forget to scroll to the right to close that radical off. And then put your minus 3. Then scroll down and let's do also y equals x one more time. And let's make sure it's a perfect reflection over the line y equals x. Is it? It's perfect, right? It's a perfect reflection. So we know we did it right. So I'll leave my inverse the way I see it. Done. Okay? Questions? Feel good? Okay. So I got a worksheet that has 10 problems on it. I'm going to give you one little hint. There's only one of them that has no inverse. So don't keep going through there and just write no inverse on all of them to save yourself some time. Only one of them has no inverse. But y'all got a little bit of time. Y'all can probably get some of this done. It's pretty easy. A nice way to get back into the groove. You feeling a lot better? You were out the last time I saw you pretty hardcore, huh? Oh, that's right. You did good on it. Yeah. All right. So 1 through 10, 10 problems. Only one of them's no inverse. Y'all probably could look at them and see which one it is.